the process of capturing, liquefying, transporting actually adds to the footprint. So from a climate perspective, you can better blow the CO2 in the air and capture it and put it to use, although it feels great putting it to use, right? But it doesn't solve the emission. So what you see happening around the globe is that large emitters, they know this, of course, the large emitters, they continue or increase capturing CO2 in their process, but instead of putting it to use, they are redirecting that supply chain to permanent storage so that they neutralize their emission. We call that CCS, carbon capture and sequestration. So it goes to empty oil wells, or they mineralize it and put it in building materials or store it subsurface, which is great. That's exactly what large emitters should do. They should neutralize their emissions, decarbonize. If they don't decarbonize, then neutralize, right? But stop your emissions.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm excited to have Rob van Straten on the show today, joining us from the Netherlands. Rob is the CEO of Skytree, a company developing direct air capture or DAC technology. DAC addresses climate change by pulling CO2 directly out of the atmosphere. There's a huge diversity of approaches to DAC, but probably the most well-known are things like the big Climeworks facilities capturing tens of thousands of CO2 per year and then storing that underground. Skytree has a different approach. They're building relatively small systems, but much smaller scale than these kind of big installations, which allows Skytree to place their systems where their customers are, and then their customers use the gas captured on site instead of CO2 from other sources in sectors like vertical farming and greenhouses. The tech was first developed for the International Space Station and spun out as a separate company a decade ago. One of the things that first caught my eye about Skytree is the commercial traction they've already achieved relative to others in this growing industry. As CEO, I think Rob should be able to help shed some light on how they've done that. To introduce him quickly, Rob, it looks like this is your fourth turn as CEO in a variety of companies spanning finance, sustainability, and technology. Right before joining Skytree in 2022, you were the chief revenue officer at EVbox, a company focused on expanding infrastructure for electric vehicles. I'm very curious to hear how that led you to Skytree. So Rob, thanks a lot for joining today. It's good to have you.
Well, thanks for having me, Dylan. Look forward to it.
I don't think I've had a guest from the Netherlands, but I'm actually really curious what the vibe is there around sustainability and climate tech, because I think of Amsterdam or as the Netherlands as this country that has quite literally been holding back the forces and pressures of climate change in the form of rising sea levels for centuries, right? I'm just curious, does that translate to a really active climate tech and sustainability ecosystem there?
That's a great analogy. I didn't think of that before. And now you started. The rising sea levels made the Dutch develop windmills in 16-something because the sea was coming closer to Amsterdam. And then the windmills were used to pump out water, build dikes, and then pump out the water so you can live below sea level. But then they thought at the time, well, that's a cool technology. You can also use it to build ships with from wooden planks, right? It's a big sewing machine. So this was the first, almost like the first industrial revolution. Wind energy used to build ships. What do you do with the ships? You sail, you start trading. That's how the tiny state of Holland in 1650 became the richest country in the world because of the water, the windmills, the ships. So Skytree is certainly one of the companies in the climate tech arena in the Netherlands. So who knows what will happen? We're back after 400 years.
And can you tell me the kind of origin story for Skytree? And I'd be curious how that intersects, how you ended up intersecting with that.
Well, I wasn't there when the company was founded. The company was founded by a scientist called Max Beaumont. Max worked at the European Space Agency on a technology that was called at the time the CO2 scrubber. And that was a technology designed to take the CO2 out of the cabin of the International Space Station to keep the astronauts alive as part of the life support system, water, oxygen, CO2. And Max was fascinated by the technology. I think it was 2014. And he started Skytree through an incubator program of the European Space Agency, as he thought, well, taking CO2 out of an area, that's an interesting technology. And he started to fantasize what you could do with it. That was about the time that Carbon Engineering and Climeworks were founded as well. So what Max did is with a small group of scientists, he first brought the technology from, let's say, space conditions to terrestrial. On Earth, you have weight. You don't have vacuum to move gases around. You don't have unlimited space like you have in space, and not unlimited funds like you have from ESA. So with a group, he spent the first few years on building prototypes, very small prototypes, discovering use cases, living off of subsidies and some private investments. And then in the years 2017 to 2021, he focused on automotive. And then the idea was, so Skytree worked for 5 years on the idea that taking CO2 out of a cabin of an electric vehicle would enable that vehicle to recirculate the air instead of taking air from outside.
So you don't have to use energy for reheating or cooling the air from the outside.
Yeah, 17% range extension. So this was like
really
the whole. Yeah, seriously. Yeah, and there were tests with Tesla, Honda, and Land Rover, Jaguar, Volkswagen, and a lot of automakers were very interested in this technology. And then, end of 2021, I got in contact with Max, and he asked me for advice and if I could help him with his strategy. And then my conclusion, coming out of automotive, electric charging, and dealing
you were
with
at
large...
EV Box at this time.
I already stopped working at EV Box.
You had been in that industry.
I've been in that industry, exactly. And I told him what he already knew, that this wouldn't lead to a viable business, as before these car makers will really integrate these filters in their cars, and legislation changes and all of it, you're at least 5 years. And then would Volkswagen or Tesla buy these filters from your 8-people company? It's a nice thought, but it will never happen. And he sort of knew that. And he also had developed this idea and built a prototype to serve vertical farms. Also, very small scale, that currently use CO2 from fossil fuel sources, driven by a truck and metal cylinders. So this was his other use case. He said, there's a big market. I want to develop machines for the global market, but I don't know how to do that. So he and the other shareholders already decided to look for a CEO who could scale up the company. And then after a few discussions, took the decision to join the 8-people company as the CEO.
Okay, that's awesome. So that was an 8-person company then. How has the company changed since then?
I think we are with 108 at the moment, 2.5 years later.
Okay, wow.
Yeah, so we've invested, I think, 22 million euro in the midst of raising another round. So you need people, you need capital, ambitions, and of course, a willing market, a burning problem. So opportunity, and I think we have a perfect mix of that. The first thing I've done when I joined Skytree was to look for a management team, specifically a CTO, who could help me, who could lead the building of the systems. The CFO was already there. He was a CFO, part-time CFO, doing several startup companies. So him and me, we decided to step in full-time. Soon I found CTO, Wojciech Glazek, who had the right industrial experience, brought on board some other people, marketing person, ST Shaikin, and others. And we started to build the company, hire people, hire the right talents. And then we developed a first product, which is the smaller unit you were referring to in your introduction. And we brought that to the market earlier this year. So we are one of the first companies, maybe even the first company, who has systems out in the field at customers who pay for that system to generate CO2, as you said, at the location where the CO2 is needed.
I want to hear more about that kind of positive impact in the context of climate change, if that's the way you think about it. So we need to be removing it depends on kind of who you listen to exactly, but something on the order of tens of gigatons of CO2 from the atmosphere to kind of meet our objectives, which is just this massive number, right? And I'm curious, like when you think about the positive impact Skytree can have, is it helpful to think about it in that context and like total CO2 removed from the atmosphere? And is your approach something that could scale meaningfully to address that?
Yeah, and you're right. I mean, authoritative sources like IPCC, they define those quantified objectives. It's echoed by BCG, McKinsey, and others who have an opinion. And how to get there is by industry maturity. It's like solar panels, right? So when the first solar panels were installed, the business case didn't work. And then a few decades later, the price went down by 95% by volume, by industry maturity. So continuous improvement in the development side and mass manufacturing. So those are the two principles that I introduced at Skytree as the foundation for our strategy. That's also how we differ from some of the other companies in our space. But so you referenced Climeworks, great company. I love them. What Climeworks and some of the other folks out there are doing is they build these sites, right? If you track what Climeworks have done, they first, then a second site, and now they introduced the concept of a third site, and it goes bigger, right? But the interval between the sites is a couple of years. And that's what's also happening with some of the other projects you read about, mostly in the US. They take time to develop, right? So a site, you need to work with the local community, with permits, and then you need to engineer that site, and that takes time. And that's great. I want them all to be successful. What we do is something different. We are developing machines, products. We first developed this small system, which for us is a stepping stone and a learning, which we used to build our flagship product, Stratus, which has a capacity of 800 kilos a day. So times 360 is your tons. And we produce that in mass manufacturing. And then when you want to build your 36,000 ton a year or 500,000 ton a year capacity, you build a deck park like you build a windmill park. So we don't design a large scale site. We mass produce large products that are transportable with standard transport to anywhere in the world. And then we've optimized those machines for every climate. So like tropical or Middle East or Alberta so they work everywhere in optimal conditions in any climate. And then we made them field upgradable so that if we come up with a new generation of capture material in the machine, we can easily replace it. So that units that you install today can be upgraded to a higher capacity or a lower electricity consumption in, let's say, 2-3 years' time when the next generation comes to the market. And these very simple principles make us attractive for two things. First, the deployments of these large-scale projects where we are also involved in, these deployments can go much easier because you can start with a system, you can start testing, then you build up a little bit more capacity because your storage site is getting ready or your downstream e-fuels process or whatever is ready to receive more. Or when your funding is there, or when you have the permit for the next piece of land. So it's much easier to deploy because you just put another system there if and when you need it.
Right.
They're
It's
individual.
modular.
It's super modular, but also because it's not a big site, but it's closed products. We don't need all the health and safety precautions. We don't need a local crew. And it's just a different philosophy that we followed. So that's one. It's very easy to deploy. And then when you build up your capacity, you buy more of these units. And then after a couple of years, you upgrade your existing units. So your capacity goes up of your park, right? It's parks that we build. But it also allows us to do something else. And that is to put systems there where you only need low volume of CO2 in a greenhouse or at a brewery or a water treatment plant or whatever. And we put those units there where you need the CO2. And that's an immediate and immense revenue opportunity because there's so much decentralized CO2 use. So if you go to McDonald's, you get your Coca-Cola. It's not transported as Coca-Cola, right? It's transported as a concentrate. Water is added and CO2 is added, right? So what if you put a machine at Coca-Cola that takes the CO2 from the air instead of it being delivered in metal cylinders and captured in a fossil fuel process? Because then the Coca-Cola is still an emission to the people that drink it. And with us, it's made circular, right? So there's an immediate and immense revenue opportunity for us in a decentralized direct air capture universe where we use exactly these same machines for. And this allows us to quickly scale up our supply chain and quickly cost down so that also these large projects benefit from our development and mass production journey.
Okay, so that's really helpful. The long-term goal may still be large parks that have many of these smaller systems to lead to high-scale removals and storage. But these kind of distributed systems for capture and utilization at your customer sites are really fueling your growth as a company, giving you revenue opportunities in the meantime, and helping you bring the technology down the cost curve and get economies of scale from manufacturing and things like that.
I'm glad that you are able to summarize our strategy. It's robust, it's simple, it's effective.
You made it very clear, but it's helpful for me that like the long-term large-scale opportunity here isn't just about small distributed systems. That's almost like a stepping stone to get there.
Exactly. Yeah. And we have not been shouting this off the rooftop, but we won some very large projects also in the US. So we have a very, very big pipeline of projects that we're working on that come online starting 2026, larger projects. But in the meantime, we are already installing products, and increasingly we will install our larger products in Dutch greenhouses, and they consume millions of tons of CO2 every year.
The greenhouses do. Okay, wow. So I want to understand that a little bit more. So where is that CO2 being sourced today, and why is it attractive for these customers to get it from your systems instead?
Yeah, so CO2 currently in use is mostly coming from fossil fuel sources. What do I mean with that? Imagine you have an ammonia plant or an oil refinery or a steel plant. So increasingly, the CO2 that is generated in that fossil fuel process is no longer emitted to the atmosphere, but it's captured. We call that CCU, carbon capture and utilization, right? Or point source capture. So you capture the CO2 instead of it being blown in the air. Then it needs to be purified. And the toxic gases, the NOxes, the SOxes, the benzene, traces, whatever needs to be taken out. You need to bring it to a high level of purity. Then you need to liquefy it. And then you need to transport it to where it's needed, usually by trucks, right? That's currently how the process works for most of the volume of CO2 in use. Now, when you put it in beverages, or you use it for food production, or any of the other applications, that CO2 will still be emitted to the atmosphere. It's not gone, it's captured and it's brought to a location through which the emissions still will take place.
Right, just later,
like weeks or months. But not years. Right. And the process of capturing, liquefying, transporting actually adds to the footprint. So from a climate perspective, you can better blow the CO2 in the air and capture it and put it to use, although it feels great putting it to use, right? But it doesn't solve the emission. So what you see happening around the globe is that large emitters, they know this, of course, the large emitters, they continue or increase capturing CO2 in their process, but instead of putting it to use, they are redirecting that supply chain to permanent storage so that they neutralize their emission. We call that CCS, carbon capture and sequestration. So it goes to empty oil wells, or they mineralize it and put it in building materials are stored subsurface, which is great. That's exactly what large emitters should do. They should neutralize their emissions, decarbonize. If they don't decarbonize, then neutralize, right? But stop your emissions. Then further to your point, like the gigatons, if we stop all emissions today, we can't. Then still we have too much CO2 in the atmosphere. That's the historic emissions. So how do we get rid of the historic emissions? By taking it actively out of the atmosphere and storing it underground. But going back to that transition from CO2 capturing in fossil fuel processes and then putting it to use, being transitioned to permanent storage, how do these companies that currently need CO2 get their CO2 then? Well, take it from the air. So we see the whole CO2 universe as being connected. You can't say we need to do this without doing the other. And we are an enabling tool for that CO2 transition and CO2 permanent removal, right? So it's all connected. So we combine CO2 use and CO2 sequestration.
Is the price of CO2 increasing for these users of CO2, like the greenhouses and the beverage companies, as more and more of that kind of industrial emission CO2 is being stored underground?
Yeah, it's the right question to ask. If you look at the issues of the fossil fuel CO2 supply chain, there are a couple. We just spoke about its postponed emissions, right? So what is the cost of that? Well, the cost is not charged to the company. The cost is charged to society, right? But okay, let's leave that aside. Then in a lot of countries, you see increasingly sticks, not carrots, for those emissions, right? In Europe, we have ETS. There's carbon taxes popping up everywhere, or other forms of punishment, which steers away from those postponed emissions. There are carrots for CCS, and there are other incentives. So the price for fossil fuel CO2 will go up, while the price for, let's say, circular CO2, for instance, from the atmosphere, will come down by industry maturity, by carrots, right? So and you already see convergence points. We can compete in certain pockets of markets without any subsidies. We can compete with the fossil fuel industry. In some industries, we can't compete because the fossil fuel industry is subsidized or because we're not low in cost yet, right? The other issue we have in the fossil fuel CO2 supply chain is CO2 shortages. So irony is that there are often CO2 shortages.
Yeah,
enough in the air, but it's a serious problem. If you Google now, or anybody listening to this, Google on CO2 shortages, US, Virginia plant, or Southeast, there are huge problems. In Australia, there have been enormous problems. In the Netherlands here, there was panic because organs could not be transported anymore when Yara stopped production of fertilizers when the gas price was high. I mean, there's a lot of industries depending on these supply chains from fossil fuels for their CO2. And there's often disturbance of supply chains because there's energy spikes or even long-term maintenance. If a big plant is doing, like is currently happening in the US, when a big plant is doing maintenance for weeks, the CO2 just stops. In Canada, it was, I forgot which town, or was it US? Last week, one of the suppliers of CO2 called force majeure. And they just stopped delivering to all their customers. So supply security is a thing.
So you're offering having a DAC system on site gives your customers as CO2 users independence from that kind of supply chain volatility.
Well, one thing is for sure, there's always CO2 in the air.
Right. Yeah, there will be too much of it for a while.
Too much of it. So why don't we take it from there?
Yeah.
Yeah, exactly.
What about from a carbon accounting standpoint? Like, can you just look at it in terms of like, what is the carbon footprint of a ton of CO2 used from these kind of industrial sources versus a Skytree? Because there is energy required, I assume, all right, for your process. There's some embodied carbon in your equipment, but then you don't have all the transportation and as much of the processing costs and everything. Yeah, what does that look like?
It's a great point. Of course, you need to have a carbon footprint gain big enough to justify the transition from a climate perspective next to economical elements. So we call that the LCA analysis, life cycle analysis. Exactly as you say, energy is an input. You need to look at the carbon footprint of your energy and of your materials, the transport of your system, the service. If you do a good job, you take that all into account. We assume that we don't use grid electricity from a non-renewable source. Because if you do that, then your delta is just too small. Why
It's
would
not
you?
good. Yeah.
It's not good. And what we do to reduce the electricity that we still need is use what we call thermal energy, hot water. Because our technology is based on the technology family, which is called sorbent-based temperature swing in vacuum. That's a common use technology. And we integrate and it's low temperature, let's say 100 degrees Celsius, that we need to unleash the CO2 from the capture material. And this is the part of the methodology that eats up most of the energy, is the heating. And if you need heat, then there are better ways to produce that than through electricity. For instance, by integrating with a hot water source that is available on site where we install our equipment. What Climeworks has done is a great job integrating with geothermal heat in Iceland. Well, a large portion of Dutch greenhouses actually also use geothermal heat, right? So we can use that hot water circuit. But also, we're working on some very large projects where we work together with large emitters that have this carbon capture and sequestration infrastructure. So they capture their fossil fuel CO2. They purify it, liquefy it, and then transport it through piping to an empty oil well, for instance. And we are developing projects that we sit next to that industry. We build our deck park, not in Wyoming, cutting trees, but on the industrial side. Use the same piping, use the same storage, the empty oil well, use the emitter's capital, expertise, and also use their industrial waste heat from their process to power our machines. And in this way, we mix in atmospheric CO2 in the CCS infrastructure that the large emitters are building everywhere around the world, so that they can add negative emissions to their infrastructure, which allows them to solve their historic emissions. And that way we bring down the energy. And what we don't want to do is use grid electricity, renewable sources of grid electricity that compete with people consuming or companies consuming renewable electricity. That wouldn't make sense. We don't want to do that. But there are places where you have abundant renewable energy when the wind is blowing very hard in the wind park or the sun is shining hard when there's a lot of PVs. So we can use surplus energy. We use adjacent technology where we use the power of the sun to heat up water, solar thermal systems, and then we run that hot water through our circuit. So we use the energy of the sun, the energy of the earth, the energy that is wasted in industry to power our machines so that we have a big carbon gain or a high LCA value, if you will. And further than that, we're looking in cradle to grave, sustainable sourcing of materials. We don't mind if there's a little bit of a premium in certain materials because they are recyclable. We take that all very serious. It's a design in our company.
So you're kind of limiting the net energy increase required for the capture by being smart about kind of where you get that thermal energy, which is that absorption process. Yeah.
Spot on. And the other is reduce the energy that we need in the first place per kilogram of CO2 or pound.
By designing your process to be as efficient as possible.
And developing the capture materials. So we work together with industrial partners like Ecolab, headquartered in Chicago. And we published that partnership, but also others because we know that the material can improve. Its thermal conductivity, its functionalized surface, capturing more CO2 molecules and reducing the sensitivity for water, because we also capture water, unfortunately. So we need energy to get the water out. So we know, the science is known that it can be improved. But it's a matter of developing that with our knowledge, with the data we get from our field installations, and then the R&D team in this example of Ecolab, great people, by the way, great company. They come from the water purification industry. So together we modify this material or we develop the models, use AI also to develop these models to come up with different sets of attributes. They then do like experiments and samples. And once they created samples, we test them in our labs. We also mix that with composites and the like. And there's a lot to gain in the effectiveness of that capture material, so that with the same liter of that material, you capture like twice the volume of CO2 at half the electricity or the heat and energy per kilo. So then now with this example, I gained the times 4 on costs. And then remember what I said earlier, and then we can take that new material and put it in existing machines in the field.
I see. So you'd go upgrade, your kind of installed base with new sorbents as they come online. Yeah,
exactly.
Yeah. So you joined in 2022, right?
1st of February 2022.
2022, and it was still sort of, maybe we're doing this automotive play, maybe we're getting into the greenhouses and vertical farming space.
Yeah.
In 2 years, now you already have installed systems at customers. I don't know what state the hardware was when you joined, but I'm curious kind of how much things have evolved in that time period and what approach you've taken from a sort of physical hardware development standpoint to get to a place where you're actually able to sell and install systems in a pretty short period of time. That's what it sounds like to me.
Yeah, you're right. It's record time. I think we are amongst the first companies bringing actually a technology to the market. So I think Wojciech, our CTO, came on board per the 1st of April 2022. And in September, it was August, we had a prototype. It were tubes and wires, but we actually put it at a vertical farm in Amsterdam called Groweye. They were willing to test with us. And that system, it was like 2 meters high by 1 meter by 1 meter, crazy. It looked like really a spacecraft thing, but it worked. And it did 1 kilogram of CO2 a day, 24 hours, 1 kilogram. Then the next iteration was a couple of months later, and that was a system, I think it was 3.5 meters high, and it was so heavy. It was incredible. That did 3 kilograms a day. Then in June 2023, we introduced publicly what we called at the time the Skytree Model 5. Well, you can guess where the 5 stands for, 5 kilograms a day. That was as big as an American refrigerator on its side. And we introduced it at the Green Tech, the big agri-tech innovation show in Amsterdam. And we won the innovation award with it. Skytree Model 5. Great, right? And then we continued to develop and we brought to market. So we shipped our first system. We call it Cumulus, not Model 5 anymore for obvious reasons. And the systems in the field, they do 12 kilos a day. Then we brought our version 2, which is shipping now, that does 20 kilograms a day. And in April next year, we will bring our version 3 on the market that does 30 kilo a day. So that gives you a bit of impression on the velocity of innovation, the difference between building products and building sites. We have such a high velocity of innovation because we can just build a product. We can build 2 products at a time. And now we are building the Stratus that will do 800 kilos a day. It's a bit bigger. But we first brought a product to TRL 9. And we took all these learnings to develop our flagship product that does the hot water integration and all these things that I told you about. And it's great to see because Wojciech has now an experienced R&D and engineering team that are building their 4th generation of deck, scrutinized by the real life of paying customers who need CO2. Yeah. That helps a lot, I can tell you. Great lab facilities, a pipeline that is frightening in its size. It's overwhelming, ambitious, many ambitious capital, I always say to Wojciech and his team, or we say, hire the best talent we can find in the world. We've got 33 nationalities with 108 people, right? Hire the best talent you can find. Give them everything they need to succeed, and then get out of their way. That's what we implemented. So
Sounds like it'd be
capital.
yeah.
I'm often fundraising.
Yeah. Well, it sounds like it'd be a fun place to be an engineer.
Oh, yes.
Yeah.
They get all the
But
toys they want.
I think that I'm glad you walked through that, because I think that really illustrates the power of kind of having a system really like size that you can iterate quickly. I mean, it sounds like your kind of iteration cycle is on the order of months instead of years. And that just enables so many things to mature quickly. And also getting that customer feedback, real paying customers. I hear over and see it over and over, like how valuable that is relative to anything you might do to try to simulate that.
I agree. And we are very fortunate that we are in the Netherlands and focused on Dutch greenhouses, because when you grow tomatoes and you sell them to the big retail chains, and they know exactly what your cost patterns are, right? It's not like, I could sell my tomatoes for a big premium. It's a commodity. Yeah. So what I'm trying to say is there's no more critical buying audience for DEC than Dutch greenhouses. They don't want to pay anything. So we are forced to drive down our costs, get our service programs to work. It's like a New York restaurant. If you can make it in New York, you can make it. It's the same with DEC for Dutch greenhouses. If you can sell to them, you sell to anybody.
That's awesome. That's a good place to start then. I'm sure there have been many, just because I know how hard these things can be. But if you were to pick out any sort of technical hurdles your team has had to overcome, is there something you would call out in that process?
Yeah, we had to pivot our technology. I think it was October 2022, if I remember well, because we figured out it can't work. The sorbent lifetime will be like 3 months or so. We have to take out the oxygen. We figured it out. We have to take out the oxygen, and you can do that in liquid form or with vacuum. And we decided to go to the vacuum route. But then that was like half a year delayed, and we had like smallish investors on board. So I had to get back to these investors, say, I promise we will bring the products to the market. So then we had to raise capital while we were in trouble. So that was a bit of a scary moment. That was probably the biggest hurdle, but there was no other way. So we made a pivot. We also made a pivot when we went from our small system, Cumulus, to our large system, and decided to deviate from the temperature swing. So we don't swing the temperature. We just maintain, let's say, a cold and a hot part in our system. Because if you
move the sorbent?
And we move the sorbent. Exactly.
Okay.
Yeah. So I've seen one other DEC company doing that, spin-off of Google. They're on the same path, but I didn't analyze all companies. And the big benefit of it is that you don't swing, so you don't have to heat up. You keep something hot. And that is less energy than warming it up. And it's easier to integrate that with a hot water source, because you can just be in a circuit and take the thermal energy of that water, and it will cool down a few degrees, and it goes back to where it came from. And also that, let's say, moving bed configuration allows us to do these easy upgrades of sorbent, because it's easier for us to suck the sorbent out. And compared with a fixed bed, where the sorbent is often glued to aluminium or metal plates or whatever, you don't have to heat up other material than the sorbent. So this is also has a lot of benefits, this architecture, but it's also challenging because you have to move sorbent around to your machine. And that's an engineering challenge.
Industrial automation challenge now of how to move that around. Is it a powder?
Yeah, exactly. It's not really a powder, it's little beads. But yeah, there's a lot of experiments going on in mixing that material with more conductive stuff, or grinding it, or putting other stuff in it. That's what we do. That's our R&D.
Right. Cool. I'd love to see it in person.
Oh, I should say come to Amsterdam. We would love to show you around.
I would love to.
It's an invitation.
All right, I'll take it. I have 3 questions for you that I ask everybody at the end of each episode. The first is, how optimistic or pessimistic are you about the future of our planet and why?
I'm not too optimistic, to be honest, because we are the dinosaur and the meteor. People cannot relate their personal behavior, the day-to-day. I step in a plane too, right? And for us, it's just very difficult to connect that with the bigger disasters that we unleash with our behavior. I am optimistic of the ability of human beings to invent stuff. And I think our lives in the next few generations will drastically change. The velocity of evolution is higher than ever, and it will not slow down.
Who is one other person or company doing something to address climate change right now that's inspiring you?
Oh, definitely Climeworks. They've been a great example for me. I've studied them. I was completely new to this whole industry, and I think they've done groundbreaking work, and they really inspired me. I think they're doing great work.
Awesome. What advice do you have for someone who's not working in climate tech today who wants to do something to help?
Buy carbon credits.
Oh, yeah.
You can't buy them from us, but you can buy them from our customers, like Deep Sky and some others that we will publish soon.
Yeah, that's a good one. I don't know that anybody's said that before, but that's a pretty clear, direct way to do it.
Yeah. Put your money where your thoughts are.
Yeah. Well, Rob, I really appreciate your time. That was really fun and inspiring for me. Thanks for everything you're doing.
Well, thanks for having me, Dylan. It was a pleasure.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.